Bismillahirrahmanirrahim. Welcome to Dr. Kate's Academy. My name is Engineer Rahman Ali Khan. Let's start the lecture number 5 of Building Construction Engineering. The outline of this lecture are to define and discuss deep foundation, its elements such as pile cap, and piers. And then we have to discuss where the deep foundation is applicable. After that, we have to discuss the classification of deep foundation based according to function, according to material, and according to construction. After that, we will discuss the stages of installation, and at last, we will discuss the pile load test. Deep foundation. So, a deep foundation, it is a type of foundation that transfers the load of a building to deeper, more stable or rock layer when the surface soil lacks adequate bearing capacity. So it is used for construction requiring high load bearing capacity such as high-rise building, bridges, and heavy industrial facilities. So we can simply define the deep foundation as in which the length to width ratio is greater or equal to 4. So deep foundation in broad term is actually known as pile foundation, and we provide the deep foundation when the foundation soil is incapable of supporting the structure load. Deep foundation is provided below the ground level and it is provided in the form of pile group. So the capacity of the group of pile is not equal to the capacity of the sum of the individual pile because of the interaction of piles. So sometimes we provided the pile wrap system. So pile wrap system, it is a hybrid foundation system that combines piles and rock foundation and soil interaction to optimize load transfer and settlement control. Element of deep foundation. So basic and main elements of deep foundation are piles, pile cap, and piers. You can see in the figure that this is piles and this is the pile cap and this is pier. So now let's discuss these in detail. Pile. So piles, it is a vertical structure element. It can be made of concrete, steel, or wood or timber. So they transfer the load from a structure to deeper, more stable or rock layer. So the main function of the pile are to distribute load through end bearing or skin friction, to reduce settlement, provide lateral support against horizontal force. Pile cap. So it is a thick reinforced concrete slab placed on top of the piles. So the main function of pile cap to connect multiple piles. You can see in the figure that the pile cap connects 4 piles and to ensure uniform load distribution, and it provides structure stability. So pile cap are provided in different shape depending upon the number of piles. So it can be in the form of triangle, it can be in the form of trapezoidal, squares, etc. Pier. So it's a vertical structures. Usually it can be made of concrete or masonry and that are built to support heavy load. And they are often used in bridges or large buildings. And the diameter of pier should be greater than the diameter of the pile. Application of pile. So the piles are applicable at the place where the structure has heavy or uneven loads that needs deep foundation. Removing of groundwater to keep the foundation dry is too expensive, and the construction of rock foundation is very expensive, and there's a possibility of scouring mean the erosion of soil, and when the groundwater table is high, and other type of foundation are costly and not feasible, and when the soil at shallow depth is compressible and not capable of supporting the structure, then we provide the pile. Classification of deep foundation. So piles are generally classified into the following categories. So according to function, we have 3 types of pile, such as end-bearing piles, friction cum bearing pile. And according to material, we have 3 types: wood piles, steel piles, concrete pile. And according to construction, we have 2 types of pile, The one is cast and test files, and the other one is a precast concrete file or driven file. In bearing file, so the file which rests on hard strata and act as column to bear the load of the structure are known as bearing file. So the an in bearing bearing file is a type of deep foundation that transfer the load of a structure directly to a strong, stable soil layer or rock beneath weak soil. So the file is driven or bore into the ground until it rests on a solid layer. The entire load is transferred through the file tip or end bearing. It is effective where a soft soil is present above hard strata. So the end bearing file provide high load bearing capacity, and it reduces the settlements and suitable for bridges, high-rise building, and tower, etc. Friction file. So friction file is a type of foundation, deep foundation, that transfer the structural load to the soil through friction along its surface rather than resting on a solid rock or hard stratum like end bearing. So friction pile, the pile which do not rest on a hard strata and bear the load on account of friction resistance between their outer surface and the soil and contact are called friction pile. So the pile is driven into deep into the ground. The surface of the pile grip the surrounding soil, transferring the load through skin friction. The longer the pile, the more it load carry because with depth the friction is increases. So friction pile is used in soft soil and can support the structure even when no hard strata is available, and it is cost effective and suitable for high-rise building, bridges, and industrial structures. Friction cum bearing pile. So a friction cum bearing pile is a deep foundation element that uses both skin friction and end bearing to transfer the load to the ground. So we can say that the pile which rests on a hard strata and resists the structural load partly by bearing and partly by their skin friction are known as friction cum bearing pile. So it is a combination of a friction pile and end bearing pile, making it suitable for site with moderate soil strength and deeper load bearing layer. So now let's discuss how the bearing cum bearing pile work. So the upper portion of the pile transfer the load um, partly by skin friction, and the lower end of the pile transfer the load by end bearing. So these combination provide higher load capacity than using just one method. So now let's discuss the types of piles according to material. So the first one is wood, or also called timber pile. So the pile made of wood are called timber or wooden pile. So we driven the pile by the help of hammer. So we provide the seat plate at the top to prevent the splitting of uh, pile due to the continuous flow of the blow of a hammer. And we at the end we provide the cast iron shoe to facilitate the sinking of pile. So the wooden pile are lightweight and easy to handle, and it is cost effective, and it is good for waterlogged area, and it is environmentally friendly. But we have to not use the wood piles when there is a heavy structures and needs proper treatment to avoid rot, and typically used for shallow to medium depth. Steel pile. So the pile made of steel are known as steel pipe. It can be in the form of I or H section beam or pipe piles. So the advantages of the steel pipes are it have high strength. I mean it can carry heavy load with minimal cross section, and it is easily driven through hot soil and even into the rock. Uh, it can be coated or galvanized for protection, steel corrosion, and it can be extracted and reused in temporary structure. So the disadvantages of steel pipes are it is very expensive and vulnerable to corrosion, and it creates noise during driving. You can see in the picture that it's a hollow steel tube there, which is called tubular pile. We provide the cast iron shoe at the end of the pile in order to facilitate the sinking. Then we driven this pile into the ground. Then the hollow space is filled with concrete. So these piles are known as steel piles or tubular piles. Those steel piles are also available in the form of steel sheet, which are known as sheet piles, and sometimes we provide it at the end, uh, in the end of the steel pipe, or desk, which is known as desk piles, and instead of a desk, we provided iron bladed bladed screeds, which is known as screeds piles. Concrete piles. So the piles which are made of reinforcement concrete are known as concrete pile. It is strong and durable and can bear more load than the timber pile. So piles are free from defects and cannot attacked by insects, and it is fireproof and waterproof as well. So the advantages of concrete piles are it can support heavy structures like bridges and skyscrapers, and it is durable and it is strong, and does not rust like steel piles, and it is economical for large projects. Composite piles. So by name you can see that the composite means to combine two or more things. So in general, a composite pile is made of two or more sections of different material or different pile types. You can see in the picture that this is a steel pipe and this is concrete. So we combine this. So the upper portion of this foundation is made of concrete, and the lower is a steel pipe. It may be a concrete filled steel pipe. Now let's discuss the types of deep foundation according to construction. So the first one is precast concrete piles or driven pile. So precast concrete piles are prefabricated structural elements manufactured and controlled environments and then transported to the construction site for installation. So these piles, which are generally in square, circular, or octagonal in cross section, we provided the cast iron shoe at the bottom to facilitate the sinking, and these piles are generally provide with a length of 2 to 30 meters. So these piles are high in strength and it's durable and particularly beneficial in marine and coastal environment because it is resistant to corrosion and suitable for a wide range of soil condition, um, and structural requirement, and it is very cost effective. Cast and place piles. It is also called cast in situ piles. These piles are constructed at their location in a borehole prepared for this purpose. So the process of this cast and place piles are a borehole is drilled into the ground to the desired depth. Then a reinforcement cage is placed inside, and then concrete is poured to form the pile. Stages of installation. Constructing cast and place piles involves several key steps to ensure a stable and effective foundation. So the first one is setting up a pile location. So accurately mark each pile's position on the ground. And number second is preparation of the rig movement plan. So evaluate the terrain to determine the most efficient path for moving drilling rigs and equipments. And so establish a clear route that facilitates easy access to each pile location while minimizing disruption. Bore drilling to the required depth. To use specialized equipment to drill a hole at each marked location, reaching the necessary depth as per design requirement. Placement of reinforcement cage. Carefully lower the assemble cage into the drill bore hole, ensuring it is correctly positioned and secure. Pouring of concrete in the borehole. So, and the last, first ensure the borehole is clean and free from debris before pouring. Then pour concrete into the borehole, typically using a, uh, trimmy pipe to prevent segregation and ensure uniform placement. So this is the stages of installation. Pile load test. To verify the capacity of pile, a pile selected from a number of piles may be tested before construction of pile. So the procedure of the pile load test are, we have to load the pile uh, to 200% of the design load, and we have to load the pile up to 200 in 8 equal increments, i.e. First we have to load the pile 25% of the design load, then 50, then 75, up to 200, and we have to maintain these increment when until the rate of settlement is decreased to 0.01 inch per hour. Then when we reach to 200% of the design load, we have to maintain this load on the pile for 24 hours. After that, we have to unload the pile in decrements of 25% with 1 hour between decrements. Then after the load has been applied and removed, we have to reload the pile to test the load and increment of 50%, and we have to maintain this load on the pile for 20 minutes, and then we have to apply 100% of the design load. Then increase the load and increment of 10% of the design load until failure is occurred, and we have to maintain these 10% increments for 20 minutes. So this test method is commonly considered the STM standard test method, and it's generally used for site investigation prior to installing concrete piles and writing specification. The main advantages of this test is that it is time consuming. Thank you. If you have any question, you can ask.